Okay, so 5-6 part 2, we're still graphing linear inequalities. So the idea, remember, you got to draw a solid or dotted line. You got to shade above or shade below. We just have one extra step. Sometimes it's not with y by itself. All right, so we might have to do that. And there is one on the test where you're going to have to get y by itself. So what makes an inequality different from an equation? We kind of touched on it in the warm-up. When you're solving it, if there's something happens, you do have to do that. But how about just the way it looks? There's an equal sign in which one? In an equation. What does an inequality have in place of that? A symbol, right? How many different symbols are there? 4, right? You got your less than or equal to, greater than or equal to, all right? So you're going to have the equal sign replaced with one of those 4 symbols. Did everybody recall that?
Yeah, totally recall.
Okay. All right. We're going to recall something else.
Totally recall.
Completely recall this. Now, if a linear inequality only has one variable, it's kind of a special case, right? Normally it's got the x and the y. What happens if it only has one variable? The line is either going to be what or what? You have 2 options. Yep?
Horizontal and vertical.
Right. One of these is horizontal, one of these is vertical. Does anybody remember which one is the horizontal? Matt?
X. Or no, what?
Y. Yep.
Oh, save himself.
Horizontal is when you have y by itself. So the x is when you have the vertical. So it gets a little weird because we usually said if it's greater than or equal to, you shade what? Where do you shade if it's greater than or equal to? Normally.
Oh.
If they had x and y in the inequality, it was a regular case. Say, can you put one on the board that has a greater than? Just an example.
On the side.
So where would you, if you were going to graph that line, it would be dotted, but then where would you shade?
To the right.
You wouldn't really have a right or a left here, because when you graph it, the line would look like this.
I said it's above.
Something like that.
Above.
I heard both above and below, yeah?
I just looked at my paper. I'm pretty sure.
You're pretty sure what?
It's above.
I didn't hear you.
Above.
Above. I agree.
Why, you said ears.
So when it's greater than, you shade above. How about when it's less than?
Below.
Below. Now, when it's vertical, you don't really have an above and below. Let's say here's your line right here. When it's vertical, you have a what and a what? You have a left and a right. How do you figure out which way to shade when it's vertical? Think of it's very simple. You just look at the problem. It pretty much tells you. Yep.
If you look at like the symbol, whatever it's like the way it's pointing.
Yeah.
Just move that way.
So you look at the symbol.
It's like an arrow.
When it's vertical, yeah, it's like an arrow. It tells you shade to the right. Right? If it was a less than, that would be pointing left. You'd shade to the left. So I think you guys already have this in your notes. We talked about horizontal. Which way would you shade here? I wrote it yesterday, but I'm not going to put it in again. Y is greater than 3?
Right.
That's not a vertical. You don't have a left and a right when it's horizontal.
Shade off.
Yeah, shade above. Yeah, shade above. All right. What about this one? X is less than or equal to -5. Where would you shade? To the left. Yes, you wouldn't have a below because the line goes up and down. You'd shade left because it's pointing left. Everything else is always on a diagonal. Okay, so normally if it's not a special case, you just have to worry about above and below. This is the only one you got to worry about left and right. Got that.
Yeah, they can do that one right now, mistake on their notes.
Yeah. So take a minute, graph that one. It's just like what we did in the warm-up. Make sure you put the correct line, solid, dotted. Make sure you do the correct shape.
Let me see, bro. Let me see.
All right, so first question is, okay guys,
Oh yeah.
is this going to be a special case or is this a normal one?
Normal.
Why?
Because you just go to 4 and draw, hold up the line and shit up.
So is that a normal case or what did we call that a special case? Normally you have x's and y's in the same problem.
I mean, it looks pretty normal to me, but I guess it would be a special case.
Yeah, we called it a special because it doesn't have both letters in it. Okay? So you can't look at, you don't worry about slope and y-intercept and rise over run. Like you don't do any of that with these. They're special. So Yusuf, you said how to graph it. Can you just say it again?
Go to 4.
All right, how do I go to 4?
Go up.
Up. So I'm going to go up to 4. All right.
And then draw horizontal line on
And
4.
perfect. What kind? Dotted or solid?
No, solid.
Solid. How do you know that?
Memory.
Memory? Well, for those that don't have as impeccable of a memory as you, how do you look at the problem and figure it out?
What do you mean?
Like, how would you tell that that's solid? Like, what do you look at in the problem?
The line. Yeah, there's a line here.
Yeah, it's got the less than or equal to. So if it's got the little line under it, then that tells you, okay, make it solid. Perfect. Now, one more thing.
Shade below.
I give you half credit for that. How do you know to shade below?
It says it right here in my chart.
It says it on your chart. Well, that's a good place to look for it.
Yeah.
Anytime it's a less than is shade below. So remember, you just can go, this is fine. You don't have to be,
As we said yesterday, I think that all the numbers that are less than or equal to 4 are going to be below it on the graph. They're not going to be above it.
so remember what that shading means is you could go, pick any number you want, right there. This point, whoops, not that one.
Oh, shit is so comfy, bro.
This point is a solution.
I love this shit.
This point is a solution. So is this point, this point, this point, this point. Any of these points are solutions to the problem because those are where all the numbers are less than 4. If you go up here, no. If you pick a number up here, it's going to have a y value bigger than 4. No, the problem said less than 4. Okay?
That one.
Okay, so one more special case. Take like 60 seconds to try it out. However you want to go.
You graph it. You want
Alright guys,
that number.
let's look at this one.
It's that -3.
Okay, again, another special case. You don't have to worry about like y-intercept and slope because there's only one letter. Can somebody else that didn't do the last problem tell me how to do this one?
Oh yeah. It's just
Let me do someone. You did the last one. Let me get someone else for this one. I'll come back. I'll come back. How about Matt?
Oh yeah.
So at -3,
Okay.
do a dotted line going vertically.
Okay, so -3. 1, 2, 3. And he said make it vertical. And how do you know it's dotted?
There's no line that maybe greater than sign.
Yep, there's no line under it. It's just a greater than. Make it dotted. Are we good?
No, you got a shade
We got a shade.
to the right.
Yes. Right? Normally we look at above and below. There is no above and below here. Above really means to the right. Right? So we're going to shade everything right. And again, if you just go like that, that's good. Everything to the right of that line. Okay. Question on that? All right, so now I think most of the other problems we look at today,
There's one more practice mistake.
is it a special case?
No.
So most of the other problems we do now are going to have both x's and y's. This is just a normal one. So now you got to look at the slope, look at the y-intercept, and graph it.
Remember guys, the stuff you need to graph it, work from right to left.
All right, guys, let's look at this one. First thing, is that equation set up the way you want it? Is that in the format that you're looking for to do a graph?
Yes.
Yeah, it's the y mx+b. It's not y equals mx+b. It's y is less than mx+b. That's fine. Okay? First step. What's the first number you use there to graph it? You gotta look at this number first. You gotta look at the 5. What does the 5 tell you to do?
To go up 5 on the X. I'm on the Y, my bad.
Up 5 on the y-axis, and then what? Put a dot.
Put a dot.
1, 2, 3, 4, 5. So that means my line is going to go right through that point. Now, I need some more points. What number there is going to help me get some more points?
-2.
The -2. And usually we like to think of it as a fraction. So how could you make it a fraction?
-2/1.
Yeah, put it over 1. So now from the y-intercept, these are like directions. Go this way 2 units, go this way 1 unit. Which way? Down 2.
Over 1.
I'm confused. Right 1. All right. Down 2, right 1. Down 2, right 1. Now, that's probably enough. I just tend to do like the whole thing. So down 2, right 1. I mean, it doesn't take me that long to do that. So there's your line. What kind of line do I put in? Solid or dotted? Right? Dotted. Perfect. We already did that one earlier. Doesn't have the equal to. Let's put in a dotted line. Maybe about like that. Let's see what we got. Put that right there. That's pretty good. Now, one more thing. Where do I shade?
To the left.
Okay, this one's almost kind of vertical, so you could kind of think of it as left, but usually we think of it as what? Below. Yeah, but I mean, it's getting kind of vertical, so I see what you're saying. Right? So we're going to shade underneath the line. Right? Again, that's fine. Okay. Questions on that one? Okay, so pretty much kind of like what we did yesterday. Now, we're going to get into some newer stuff.
So guys, we'll do this one together. That's one,
Okay, so Mr. Roy is going to go through this one with you. And it's going to be just like the last one, except there's one thing you got to do first to kind of set it up.
So, like we talked about yesterday, like the steps that we have to follow, right? The first thing we have to make sure of is what? It's going to be in y equals mx plus b, right? So like we said at the beginning of class, this getting y by itself is the only thing that's really new today. The steps to graph it are exactly the same. This is like really the only new piece, and then the word problem will do. Everything else is nothing new. All right? So to get y by itself, what do I have to do? That's the first thing, right? Subtract 3x from both sides. Good job. So minus 3x, minus 3x. So right on the left-hand side, over here, here's my sign. On the left-hand side, what am I going to be left with? No. So this is going to cancel out. What's left?
X.
Nope. Good. Melanie, 2y, right? That's the whole reason why I moved the 3x, right? To start the process of getting y by itself. So I got 2y, right? Greater than, what's going to be on the right-hand side?
+8.
Good. Negative 3x, and then plus 8. So negative 3x, like Nicole said, and I heard Donovan in the back saying plus 8. I agree. Right? The whole reason why we did that was just to get it in the right format. To make sure it's in the right order, to make sure it's in slope intersect. Alright? So Dylan, the last thing I have to do, because y is not by, I'm telling you, y is not by itself yet. To get it by itself, what do I have to do? Divide by what number? 2. What am I dividing by 2? Everything. Think of it like the last step in an equation, right? The last step in an equation is you have to divide, right? Same thing here. Using an equation with an equal sign, we have one thing on one side, one thing on the other. We just do both of those things. When we have to get y by itself, when we're graphing, we're just going to make sure we multiply everything. Usually it's 3 things by that number. So the whole reason why I did it was to get y by itself. There it is. Here's my sign. Now how about negative 3 over 2? Does that simplify? Does 2 go into 3 evenly?
No.
So what should I do? Just leave it like it is. Because in this problem, that negative 3 over 2 is going to be the what? It's the slope, right? And slope is what, Donovan? 1 over what?
Rise over run.
So if you have the number with x as a fraction, that's okay. Because it's rise over run anyways. If this, now the number at the end, the y-intercept, if that comes out to be a fraction, it'll still work. It'll just be a little bit more tricky to graph. That's all. So when I simplify 8 over 2, what do I get? 4. So there's my equation, or my inequality in slope-intercept form. All right? So Nathan, to graph that, what do I do?
No, you put a dot on 4.
4, which axis?
1.
The y-axis. So that means I have to go up 4. 1, 2, 3, 4, put a dot. Awesome. Miguel, from there, what do I have to do?
You have to go down 3 and over 2.
What do you mean over?
Slope.
Which direction? Can you say over? I agree with down 3.
Down.
Okay, I know down 3, I agree. What about when you say over, what direction? To the right. Remember, even if the guys in the corner, if you can't handle sitting down, I'll make you move. So we're gonna go down, like Miguel said, 1, 2, 3, and then remember, even though the slope is negative, we're still gonna treat that bottom number as if it's positive. Always going down to the right if the slope is negative. 1, 2, 3, 1, 2. I'll put a dot. Like Mr. Hager said, you can keep doing it. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. If I do it again, I'm gonna end up going off the graph. Right? So there's my dots. Now, Brady, what type of a line is it going to be? Solid line, right?
Good job.
It's your center, Yusuf. All right, so there's my line. Now, how about use of shading?
Above.
I'm going to shade above, right? Because it's greater than. All the numbers that are greater than are going to be up here.
That's right.
All right, and there's my shading. So the shadings, even if you have to get y by itself, it doesn't matter. You're still gonna do in terms of the process of graphing it, how the lines, it's gonna be dotted or solid, where you're gonna shade. That's exactly the same. So only new piece here, and we've done this before with slope intercept, was just having to get y by itself. Other than that, everything else is the same. All right, people good with this? Now, this one, I want you to somewhere, probably on like this is example 2C, so maybe like underneath the graph, you may want to write this, right? Remember when you divide by a negative, you have to flip the inequality sign. So for this one, I'm already telling you that you're going to divide by a negative. It's going to happen. So probably, like I said, right below the graph, you may want to write this. This might be important for the test on Friday. When it says it, you can just write it right below the graph. And then in this problem, once we flip the sign, you can always like circle it and draw like an arrow down the way you wrote this. And this will definitely be one that's going to be on this will definitely be one that's on the reference sheet. And again, if you don't fill out the whole reference sheet, this may be one that you may want to put because it's a little different because we have to flip the sign. Same thing, like some people have to look back at their notes to be able to decide whether it's dotted or solid and where to shade from the chart. That chart is on the reference sheet that's on Google Classroom. So if you want to just fill out that chart in this example, that's fine. All right, I'll talk about that at the end of class today. Because remember, the reference sheet is optional. You don't have to do the whole thing. Just fill out what you need. If you want to fill out the whole thing, that's fine too. All right? So this one is everything the y, the slope, the y-intercept, are all those things in the correct place? Yeah, everything's in the right place, so we don't have to move anything because everything's where it needs to be. What's the one thing in this problem that we have to do?
Simplify.
Simplify? And what do you mean by simplify? What do we have to do?
Divide all the numbers by 2, or -2.
-2. So I'm dividing by -2. So whole reason why I did it was to get y by itself. There's my y. I'm going to skip the sign, or I'm going to skip over that, so I'm going to leave a little space for the sign. I'm going to have 4x divided by -2. What do I get? -2x. And then +8 divided by -2? -4. Good. Why did I leave a blank for the sign? Obviously I have to put it, I need it.
Because you're putting the greater than? No, that's the less than.
So it's less than here, what's it going to become?
Less than or greater than?
No?
I mean, less than or equal
You're
to.
proving that sign.
Like Yusuf just said, like Nicole just said, I'm going to flip the sign.
I'm big dumb.
So I'm just going to circle it, I'm going to draw an arrow down here. We had to flip the sign because we divided by a negative. So the one we did before this, example 2b, it was more steps because we had to move the x and then divide by y. But we didn't have to flip the sign because we divided by a positive. This one, we didn't have to move anything. Like Donovan said, we just had to simplify, which was dividing by -2. But that caused us to have to flip the sign. Because we divided by a negative, we had to flip the sign. Alright? But in terms of graphing it, the steps we do to graph it are the exact same way. They don't change. Alright? So Alex, to graph this, where am I going to start?
-4.
-4 where?
On the left.
On the y-axis. So what does that mean I have to do?
Put down 4, put a dot.
Go down 4 and put a dot. Good. 1, 2, 3, 4. There's my dot. Jake, from there, right? So Alex just told me -4 is my y-intercept. We start at the origin, we go down 4 on the y-axis. We've used that. From there, where am I going to go? From the -4.
I'm two to the right one.
What did she say?
To the right one.
What's my slope? Oh, we just used that. It's the y-intercept.
-4.
Nope. That's done. Once I graph the -4, it's done. I don't need it anymore. Remember, we're going to work from right to left. So I just got my y-intercept. I'm going to use this now, right? The number with x is my what? Starts with an S. Slope. What's the slope telling me to do? If it's negative, what direction do I go?
Down.
Down how many?
2.
Down 2. And then what direction, Jake? Right or left?
Right.
Right. Remember, I'm still going to treat the bottom as if it's positive. Or even if it's a negative slope, I want to go down to the right. So I'm going to go down 2, 1, 2, right 1. Down 2, 1, 2, right 1. 2. Again, guys, like Mr. Hager said, you can do it you can do it a couple times. You don't have to do it as many times as we do. We'll have a general idea when you graph it, if it's correct. All right. Page, what type of line? Solid or done? What do you think? Solid or done? Jake, help her out.
Solid.
Why?
There's a line underneath.
Yeah. Look at the original inequality sign, right? Oh, oh, guys, I lied. No line underneath. Jake, I tricked you, buddy. What's it gonna be?
Solid.
Dotted, right? No line underneath. Dotted. Line underneath. That's the reminder to say make sure you make it solid. So this one's gonna be dotted. Get a thing here. I think Mr. Hager does this for me. right, shading. Who knows? Would you like shading? Above or below? What's a greater than? Above, right? And again, if you're not sure, make sure on the reference sheet, fill out your chart. All right. So this one will be above. I'm not gonna get fancy here. Oops. There it is. So the only thing different about this one was we had to flip the sign. Alright, everything else the same. Alright? So the only thing that could trip you up on that one a little bit is if you don't flip the sign. Other than that, nothing's different. Last one. Word problem. Ooh, baby.
Oh my word.
All right, and again, guys, on the test, on the homework, we review tomorrow. You'll have your like the graph you have to use will be numbered for you. You don't have to like figure out how to number it. It'll be all set for you. All right, so it says you can spend at most $10 on grapes and apples for a fruit salad. Grapes cost $2.50 per pound. Apples cost $1 per pound. Write and graph an inequality that represents the amounts of grapes and apples you can buy. All right, so for grapes, let's use G, and then for apples, we'll use A. So grapes will use G, apples will use A. And guys, this isn't like a system, like last week we did like systems, we had to like set up 2 inequalities, or 2 equations. We're only going to write 1 inequality for this. That's it. We don't need 2. We're only going to do 1. All right, so cost of grapes. I'm saying this extended up. Cost of grapes plus cost of apples. I'm going to type that in. It's going to equal total cost. All right. So we want to know. We don't know how many apples or grapes we bought. But we know how much they cost. Kind of like last week, we knew how much, like when we had like the 20% solution, the 30% solution. Like we attached a variable to that number. We're going to do the same thing here. All right? So how much do grapes cost per pound?
$2.50.
$2.50. So I'm going to write, and Mr. Hager has it set up, $2.50. What variable that we already determined, what variable is going to be attached to that 250? G. You can use X and Y, you're not wrong. 250G. Because it says you can spend at most $10 on apples and grapes. That's how Mr. Hager knew it was plus. So we're going to put a plus here. How much do the apples cost?
$1.
A buck. What variable will be attached? A. Then it says equals, well, it'll be total cost. But now we're setting up an inequality. So we got to be careful not to use an equal sign. Every once in a while. I got to be careful not to use an equal sign. What word or what phrase in this sentence, in that first sentence, is going to tell me what sign to use?
At most.
Good. At most. That means I can spend no more than $10. $10 is the most I can spend. But think of it this way. I can spend $10. I just can't spend more than that. So I can spend up to $10.
So it's less than or equal to?
It'll be less than or equal to.
Change that to X. So then, that's less than or equal to.
Yeah. Less than or equal to 10. But now, so I'm close in terms of having my inequality set up. But This is perfect. Attaching the G to the 250, the A to the dollar. That's perfect. That's perfect. But what about if I wanted to graph this? Can I graph it?
No.
Nope.
Why?
Because
Not in slope-intercept. All right? And like Mr. Hager just said, this is the letter to get alone. So we can think of like the G as the X, and then the A as the Y. So the number that's like closest, the number that's immediately to the left of the inequality sign, that's what we want to get by itself. On the test or on the homework, if you want to use X and Y just to make it a little bit easier, you can do that too. All right, so Mr. Hager just told us we want to get A alone. So what's the first, this one, in terms of getting it, in terms of being able to graph it, it's going to have two steps. What's the first step? To get the A or the Y alone. Nicole, do you know? Subtract 250G. Minus 250G. Minus 250G on the other side. Here's my sign. I didn't multiply or divide by a negative, so my sign doesn't flip. On the left-hand side, over here, so this cancels out. Over here on the left-hand side, what's going to be left?
1A.
1A. On my right-hand side, what's it going to be?
10 minus 250.
Careful.
250.
I mean, what we want, I should have put a G with this.
Oh, 2.
Negative 250.
50 minus 10.
Is that a positive or a negative 10?
Oh, plus.
Plus.
Stop confusing me.
All right, now, last step. We're close. Catherine, what's the last step?
Sure, you're missing a variable.
Yeah.
Oh, whoops.
Bring that G.
Squeeze my G in there. There we go. Someone tell me what's my last step? Savannah? Okay, get A alone. How do I do that? By my 1. So we know that's going to cancel out and be A. We got that. I know it's going to be negative. I'm going to do 250 divided by 1. 2.5, but we know it's going to be negative, so it'll be negative 2.5. And then 10 divided by 1, it's going to be what?
10. So it would be A is less than or equal to negative 250 plus 10.
Yeah. So that's like this is like 2. It's like 2.5. All right. So this would give you had this.
That'd be half credit.
That would give you half credit. So it asks you to write and graph an inequality that represents the amounts of grapes and apples you can buy. All right. So let's graph it first. Then we'll get to identify and interpret two solutions of the inequality. All right. So to graph this, where am I going to start?
Go to 10.
Right, mistake, would you agree, go to 10? Go to 10, but then now, I'm going to put a dot at 10. From there, where am I going to go?
Down 2.
Down 2, so I'm going to go down 1, 2, and then a little bit more. So in between 7 and 8.
Yeah.
So I'll put a dot there. I'm going to go down, but now I'm at 7.5. I go down another half.
No dot there.
Oh, no dot there.
No.
Sorry. Then we're going to go over 1. I'm sorry about that.
Sorry, I forgot to tell you that.
Sorry, my bad. We'll do the same thing. I'm gonna end up at 5, go over 1. I'll end up at 2.5.
Wait, 2 is the next one. Now
Nope.
it's at 5.
Over 1.
And then I'm gonna end up at, I'm at 3.5, I'll end up at point that, and then here. So there's my line. Alright? Now, is this gonna be solid or is it gonna be dotted? Solid, right? Because there's a line underneath.
What the heck?
Mr. Hager's going to draw that line for me. Now, where,
Now, you
because,
put arrowheads on that?
yeah,
Look at it.
Why he didn't put any arrowheads on the line he drew? Because what? So we want to know how many pounds of grapes and apples we can buy, right? Why would the line stop here? Why wouldn't it keep going through the x-axis?
Because you don't have negative money.
Yeah, you can't have. You can only buy a certain amount, and you can't have, like Yusuf said, you can't have a negative amount. You can't buy negative 2 pounds of grapes or negative 5 pounds of apples. All right, that's why we stop when we do something like this. All right. Oops. Now shading.
Below.
Am I going to shade? For this one, I'm going to shade again. It's less than, so I'm going to shade below. This thing's going to shade it in for us. Now, so we're almost done because we graphed it. We wrote the inequality. The last sentence says, identify and interpret 2 solutions of the inequality. This last sentence. Identify and interpret 2 solutions of the inequality. Exactly, Yusuf. Like Yusuf just said, you can pick 2 coordinates inside what's shaded in, and that'll tell you how many pounds of each you could buy. If it were me, I'd pick a nice coordinate that's like right on a line. Like I might pick,
The 5 one, where's that right?
I'll go here, 2, yeah, I can do that, and it can be on the line. So I can buy, it's 2 pounds of grapes, 5 pounds of apples. Because again, it's a less than or equal to. So if I do that, I won't go over $10. I'll still be okay. I can pick another. So one solution, mistake of setting it up. One solution, we just said we could buy inside. We could buy 2 pounds of grapes, 5 pounds of apples.
Can we just write the coordinates instead of like writing on the...
You can write this. You can just write 2 pounds of grapes, 5 pounds of apples. So 2, 5, you see how that works? It tells us here, it's labeled. Pounds of grapes, all right? 2, 5, it's on the line. That's okay, because it's a solid line. It's included as a solution. What's up, Bill?
Could you do like 0, 4?
0 pounds of grapes, 4 pounds of apples? Sure. 0 pounds of grapes, 4 pounds of apples. Now, my grapes, remember this is my G, this is my A, this is my G, this is my A. If I plugged in 2 for G and 5 for A, it would give me a true statement. I'm not going to do it now, but if I plugged it in, it would give me a true statement. It would be what's on the right hand side, what's on the left hand side would be less than what's on the right. So when it says interpret and identify 2 solutions of the inequality, all that means is pick 2 coordinates that are inside or on the line that you just drew, and there's 2 solutions. Now on the test, it's going to be different for everybody. You know, you guys may pick one of the same coordinates, but chances are you're probably not going to pick 2 that are the same. So for this, to identify and interpret, it's going to vary because people are just going to pick different coordinates. As long as they're on the line or inside the shaded area, any of those will work for a solution. All right? And you don't have to plug them in and prove it. You don't have to do that. Just pick 2 that are on it or inside. All right? So that's probably this. And again, there'll be one of these similar to this on the test.
Oh yeah.
It'll deal with money again. Set it up the same way. Whatever cost of the first thing you're dealing with, plus the cost of the second thing you're dealing with, and then it's going to be figure out what your sign is. In most cases, it's going to be less than or equal to because you can only spend that amount of money, and then at the end, it'll be how much it costs. All right? Homework is worksheets, so there'll be a couple on there where you have to rearrange the graph. There'll be some where you don't have to rearrange, a couple special cases. There will be a word problem, and then some system problems that we did on Monday. All right? Tomorrow, review day. Nothing new tomorrow. So probably the first 20, 25 minutes of class, we're gonna give you guys like a worksheet that has like 5 problems on it that dealt with what we're doing during the week. You guys will have time to work on that by yourself. We'll go over it together, and then after that, we'll do like a game where it's like 10 questions total. For every 2 you get right, you get a bonus point on the test on Friday. All right? We've talked about this a bunch this week. Homework, all right, will count for third quarter. So the 2 homeworks we've done so far, tonight's homework, tomorrow night's test review, will all count for this quarter. For third quarter, test grade is going to count for fourth quarter. Reference sheet, it's been up since Monday afternoon. Again, it's optional, but like we've said all week, it is helpful, especially to fill out the chart and how you shade and what kind of lines you draw. The one we did today, I think it was example 2C. We had to flip the sign. That would be a good one to get on there too. But again, you don't have to do it, it's up to you. And then, like I said yesterday, both of us will be after school tomorrow. I'll be here till about probably 4 o'clock. People want to make sure their reference sheet's all set. They want to make sure their test review, you're doing it correctly. I'll be here, Mr. Hager will be here. And again, it's unfortunate because some of you guys don't need to hear this. The majority of you don't, but there are a few of you, 3, 4, 5 of you out there that it's better to put the time in now than being in here in July and August. All right, and again, the people I'm talking about, unfortunately, are the ones that don't usually show up. So, you know who you are. I'm not going to single anybody out. You know what your grades are. Again, if it's important to you to be here, to not be here during the summer, I'd stay out. All right?